Hello, this is me again, and what we're going to look at right now is another example we did in class. This is a cost-benefit example. It's a little bit different than a resource allocation problem. Very similar, but there's a difference in terms of what we're actually trying to do. In a cost-benefit example, what we're trying to do is accomplish some benefit at the minimum cost. So remember, in a resource allocation problem, we were trying to accomplish an outcome of profit, say, to maximize that, subject to some resource constraint. Here we're trying to reach some benefit at some minimum cost. So it's a little bit different problem, set up almost entirely the same way. Here's my example. This is from the slides that were provided, the PowerPoint slides. I wanted to show you exactly how to do it here on this little video. Management has decided to undertake a major advertising campaign that will focus on the following three key products. So we've got three products: a spray pre-wash stain remover, a liquid laundry detergent, a powdered laundry detergent. The campaign will use both television and print media. The general goal is to increase sales of these products. Management has set the following goals for the campaign. So the sales of stain removers should increase by at least 3%. The sales of liquid detergent should increase by at least 18%, and the sales of powdered detergent should increase by at least 4%. Here's our question. How much should they advertise in each medium to meet the sales goal at a minimum total cost? So what we want to know are not different amounts of the spray, pre-wash, stain remover, and the liquid laundry detergent, not the different products. What we want to know are the different mediums. How much should they advertise in TV, and how much should they advertise in print to reach these sales goals? So the things I'm going to put over here on my columns will be TV and print. Okay? Now let's see if I've got my data correctly. If we go down here, oops, not that one, on this one, I pulled out my data. I've got three products: stain remover, liquid detergent, powder detergent, two media, television and print ads, and I've got a predicted change in sales from each unit of advertising in each media. So that's my sort of requirements. And then I've got a cost. That's my sort of contribution. And I'm told my cost is $1 million for a TV and $2 million for a print ad. So up here, I'm told my three products. My three products I'm going to put over here are like my constraints in this case, because I've got to achieve this. So I've got my spray, whatever that is, stain remover. I've got my liquid detergent, and I've got my powder detergent, okay? And I know that I want to advertise in TV and print ads. I know I'm going to have how much these TV and print ads increase those sales. And I know what I have to reach, my benefit that I have to receive or to achieve. Not available this time, but what I have to, my goal I have to get over is I have to increase the stain removers by 3%, the liquid detergent by 18%, and the powder detergent by 4%. So those are my requirements right there. Okay, those are my general goals. Now I also know from my data down here how much the media cost. I'm told that the cost of a TV ad is $1 million and the cost of a print ad is $2 million. Costs more to print than TV. That's kind of weird, but it does. Okay? And what I want to know is the quantity. Whoops, I'm going to spell it right. Quantity. You'd think I'd be able to spell that as an economist. I need the quantity of TV and the quantity of print ads. Those are going to be what I'm looking at. Those are going to be my changing cells, the things I'm going to try to use. Now, what I'm missing here is my requirements. How much does a TV ad help the sales of this stain remover, the spray stain remover? How much does a TV ad help with liquid detergent? Well, in the problem, they gave you a table. Oh, did I not copy the table? I didn't copy the table, so I have to go to my slides and find that table. Excuse me for a second. Here's my table, my slides. These are the slides you were given. And we go down here, we have this example. There it is. You can see right here we have it. These are the predicted sales changes. So I'm doing the one from your slides. So let's see if I can put my little thing up here. And we can see that, move it a little bit. Sorry, I should have had this set up for you. Okay. For the TV, the stain remover doesn't help at all. 0 increase. So we don't want to run a TV ad, I tell you that, for a stain remover. The liquid detergent is a 2% increase. The powder detergent is a -1. Now the reason for that is if you choose a TV ad, people who see the TV ad for the liquid detergent would maybe change to it from the powder detergent. So we've got a negative interaction going on there. The print ad does help the stain remover. It does help the liquid detergent, but it really helps the powder detergent. Do you see how I've got those over there? Okay. So I think I have all the information I need now. Let's see. I want to determine my quantity, so those are going to be my changing cells. They're going to be yellow. All this information was given to me, so that's going to be blue. And this is going to be blue, that was given to me. And these benefits are going to be blue. Now this problem, I want to achieve these benefits, so I'm going to have to put my used or achieved there. And again, I'm going to have to use my sum product because I'm going to have to take however many units, and we'll put 10 in there for now just so you can see how it works. I'm going to have to take the units of the TV ads times its contribution to this bottom line, okay? So I'm going to go over here and do my sum product. Sum product, there it is. And I'm going to say, okay, there it is. These two guys times these two guys, okay? And the next one, sum product again. And it's going to be these two guys times the quantities. Okay, and for this one, again, I need a sum product. Okay, and it's going to be these two guys times these two guys. Okay. So there's all of my used, and what I've got to make sure is, this is a cost-benefit problem, is I've got to make sure that I make at least that. I could make more, but I've got to make at least a 3% increase. So I'm going to go over here to my Insert tab, where's Insert? I'm going to insert a symbol, and this time my symbol for my constraint is actually going to be greater than or equal to. I've got to make sure that each one of these are greater than or equal to. So we've got to have at least a 3% increase in sales for the spray product, at least 18%, so greater than or equal to, okay? Now I also need my total cost, because that's my objective. It's going to be orange, so I'll go to my home and color it orange. Where's orange? There's an orange color. And it's got to be the cost times the units. That'll give me my total cost. So how many TV ads times $1 million and how many print ads times $2 million. So again, we're going to do a sum product. Okay. Come up here, go. And it's cost per unit times the number of units. Okay, and there it is. So now I think I have my spreadsheet pretty much set up. So now I'm going to go to my solver. So Data tab, Solver, there it is. Move it over so you can see it a little bit. Okay. Now I've clicked on my total cost cell, so that's my objective. Now I want to minimize it. So click on Minimize. Okay. My changing cells will be right here. Okay. My constraints, I'm going to add that these guys, and I'm going to put them all in there. When the signs are all the same direction, then you can put them all in as one constraint. And since I have all three of these have to be greater than, I'm going to put all three of those, and I'm going to choose greater than. Click the drop down, greater than or equal to, and all of these. Okay? So now I have them all listed as one thing. Now, you can do that. You've got to be careful of that, though, because you've got to remember there are three things here. And if you do some kind of a fat finger mistake and you drag it too far, drag it too short, you won't see that here. If you put them in individually, you'll always see that. So putting them in individually is probably the best way to do it. Again, I want to make sure I have simplex linear programming, and I'm going to solve it, and okay. And you can see I'm going to do 6 TV ads and 3 print ads, and it's going to cost me $12 million. So if I go to the boss and the boss says, $12 million, we don't have $12 million. I'm going to say, well, boss, if you want to achieve these goals, that's what it's going to take. If you want to change these goals, boss, we can change how much it costs. And if he says, well, okay, liquid detergent only needs to go up 10, you just change this 18 to a 10, click on your total cost, go up to solver, and resolve it. Okay, so once you get this thing set up, it's really easy to modify it, try different things. So this is a cost-benefit problem. Cost-benefit problem, you have something you're trying to achieve, a benefit you're trying to achieve, at a lowest possible total cost, given some kind of requirements, okay? So these are all linear programming models. So you could have some examples where these constraints are greater than or equal to, some where they're less than or equal to, some where they're mixed, where you have some greater, some less than. These two videos I've done for you here should get you through all of Chapter 2. So work hard. If you have any questions, let me know. Thanks. Bye.